Very good afternoon. Myself, Dr. Ravi Kumar Poluru, working as Assistant Professor in the Department of Information Technology. Till now, we have discussed Module 1 and Module 2. Today, we are going to discuss about the Module 3. In Module 3, we are going to discuss the life cycle of the phases. Okay. Here, actually, we have the life cycle phases. Okay. So these life cycle phases consisting of is divided into two types. One is engineering phase and another one is production phase. Okay. This engineering phase is again divided into two types. One is inception and another phase called as elaboration. In production, again it is divided into two types. Okay. One is construction and the last one is transition. So these are the four phases is divided into two types. So engineering phase and production phase. The engineering phase is again divided into two types, inception and elaboration. Whereas in the production, so it is divided into the construction as well as the transition. Okay. Now we'll discuss what is meant by engineering and production stages. Okay. So here in engineering, mainly when software project does not succeed, the project is not succeeded, the primary reason is they need to define about what are the main failures. Okay, such as define and execute. They need to verify whether there is a proper balance and appropriate emphasis is defined or not. If it is not defined, then the software project is, we can call as, is not succeeded. We need to balance this functionality, okay, and they need to provide the appropriate emphasis, not only in the conventional as well as in the iterative process. This is very important. If you're not providing the proper balance and giving the good define of the software requirements and the planning, then we can say that it is an unsuccessful. So that's why we need to check that whether the project is successful or unsuccessful. If it is an unsuccessful project, then we need to have some characteristics. The first characteristic is overemphasis on research and development. Okay, so mainly they need to check that R&D. Why means while they're taking the software projects, mainly they're going to verify about the paperwork. Okay, the analysis of the paperwork should not be too many constraints. If they're having the too many analysis of the paper studies, then we can say that it is an unsuccessful project. Okay, and we can consider this is an baseline as procrastinated. Why means we require the analysis of the paper studies should be optimal. Then only they can succeed. So which they need to concentrate on the empirical as well as the prompted the conventional software process. Okay, the next one is overemphasis on the production. So they should not rush to judge the designs. They need to check that whether the design will work for the future or not. They should not hurry and decide that this will be work for the software project successfully. And premature work by over eager coders and the continuous hacking are typical. So mainly here, this is the main unsuccessful projects, the characteristics. They should not judge the design parts and for the coding part as well as the checking the hacking of the things. Okay, these are the main unsuccessful of the engineering phase or software project. Mainly when you are considering the modern software development process, we need to define that evaluation. So the plan must be accordingly, and requirements and architecture must be synchronized. So the plans, the requirements, and the architecture must be well defined. The first point. And the next point is what is the risk management and how they're going to measure the objectives, the progress, and checking the quality. So they need to check that how much risk they're going to identify by using the risk management. And the next one is evaluation of capabilities through the demonstration. So mainly in the modern iterative process, the demonstration process will be happen so that if any problem is faces, they are going to rectify immediately. Whereas in the conventional, so they cannot, have a demonstration in middle of the project. So that is the main difference between the conventional as well as the modern iterative software development. Okay. Now here, mainly we are going to verify about the economy of scale and diseconomy of the scale. So we know that if the economy of scale means they are going to gain the higher return of the investment. Okay, so that mainly the manufacturing they are going to decide that two stages in the life cycle. The first stage we can call as the engineering stage. In the engineering stage, they are going to predictable very less and having very smaller team for the designing and for the different types of the activities. So whereas in the production stage, so they should be predict very heavily. So driven by more predictable but larger teams, because in the production they need to get the final product here. So that's why they need to predict very high, and the team also should be very large here. In production, mainly we have constructions, the test, and the deployment activities. These are the main things they are going to do in the production stages. Okay, so we have the two stages, it is engineering and the production stages. Whereas in the life cycle aspect and engineering stage emphasis and production stage emphasis. So now we are going to compare the how much risk they can handle between the two stages. The first one is risk reduction. Okay, whereas in the engineering stage, it will be applicable the schedule and the technical feasibility. Mainly the risk reduction will be very less in the engineering stage. Whereas in the production stage, the risk should be mainly depends upon the cost. And next one is product. Okay, so here in the engineering stage, mainly they are using the architecture baseline. So it means in the engineering stage, they are going to design the architecture part, and in the production, they need to release the product. So here the product release baselines and activities. So what are the activities will be performed in the engineering emphasis means they're going to have the analysis, design, and planning. Okay, whereas in the production, so they are going to deliver the product. So here they are using the implementation and the testing. So testing will be happen in the production stage here. Whereas in the assessment of the engineering stage, definitely they need to give the demonstration, inspection, and analysis will be performed in the engineering stage. And whereas in the production stage, the testing will be performed here because the final product will be need to deliver. And economics. So here they try to resolve the diseconomy of the scale in the engineering stages. Whereas in the production stage emphasizes they are exploiting the economy of a scale here. And here the last one is the management. In the engineering stage, likely they are going to consider the planning, and in the production stage they are using the different types of the operations to do the what are the requirements of the resources. So based upon that, they will take the different types of the operations here. Okay, in the transition between, so we know that engineering and the production is very crucial for the various stakeholders, because the stakeholders has to be discussed each and every data while they are going to communicate it between from the management as well as the developer. So mainly here the stakeholders will be having the very crucial things when the two phases like engineering and the production stage will be performed here. In the production plan has been agreed upon. So there is a good enough understanding of the problem and the solution. Here they're trying to understand what is the problem and what is the solution here, and have the stakeholders, and they're going to commit the what are the commitment they will be happen within the production. And here we have the two stages, engineering and the production, have the little codes and true simplicity, and this can be used in the various applications. Whereas in the engineering stage, it will be decomposed. So we have seen that engineering stage is again divided into inception and the elaboration, and whereas the production stage is again divided into the construction and the transition stages here. Okay, so here the four phases, we have the four phases in this diagram. Okay, and this model we can call as the spiral model, and it is developed by the Bohm in the year of 1988. Okay, here we have the engineering stage. So first it will be divided into two stages, engineering stage and the production stage. And in the engineering stage, it is again divided into inception and the elaboration. And in the production stage, it is divided into construction and the transition. Inception we can call it as the basic idea. It means they're going to consider the planning and the requirements. So whereas the elaboration, they're considering the architecture part of the design of the components. And in the production stage, so the constructions will be taking the beta releases. Okay, like implementations will be happen here. And in the transition, this is the final product which will be going to release. So here from the small, I mean, if you are seeing from the inception to transition, the spiral will be incremental, means the size will be increase in the circular form here. Okay, the spiral corresponds to the inertia of the project with the respect to the breadth and depth here. So here, based upon the inception or the transition, the size will be differed here, and this must be maintaining the consistency. So they need to maintain the consistency and regression testing, the documentation and quality analysis, and finally the configuration control. So these four stages must be maintain the consistency and have the mainly they need to check the documentation. So documentation is very important when they're doing the software projects, and quality comes very crucial role here, and they need to maintain the quality of the product. And increased inertia. So we have seen that in inception the size is little bit, and whereas in the elaboration the size is increased. So increased inertia may have a little or at least very straightforward. So based upon that it will be changing. So when we are going to add on the components or the activity here, and the reaction time for the accommodating major architectural changes. Here in the elaborations we can have the changes in the architecture, and in the construction phases we can see that this can be happen the implementation and transition, the final product here, and architectural changes and major requirement changes, major planning shifts or major organization perturbations clearly increases in the subsequent phases. So we can have that based upon that the changes will be happen based upon the plan or the design part will be accommodated here. In most conventional life cycle, the phases are named after the primary activity. So here in the conventional, we can see that the name will be performed after completion of the primary activity in each and every phases. So we know that in the conventional, we have the requirement analysis, the design part, coding, unit, and integration testing, and finally system testing. So here first it will take the analysis Okay, after completion of the analysis, it will goes to the design part, then the implementation, or we can call as the coding. This coding part will be, we can have that divided into sub modules. Okay, all these modules, they're going to verify, checking the testing unit wise, and finally these models will be integrated. We can call as the integration testing, and finally they're going to check that full modules in the system testing here. Okay, whereas in the conventional software development efforts, so mainly they're going to check that each and every process. So after each and every activity, then only it will goes to the another activity here. Okay, so this is about the engineering and the production stages. Okay, now we'll discuss in the engineering phase. Inception phase will be there. Okay, inception phase, we know that inception is nothing but it is the starting stage where the requirements and the planning will be happen. Okay, the overriding goal of the inception phase is to achieve concurrence among stakeholder on the life cycle objective for the project. So mainly in the inception, they're going to deal about the stakeholders, and they're going to check that what is the achievement or the goal in the static initial stage here. The primary objective of the during this inception phase is, the first one is establishing the software, project software scope and boundary conditions, including an operational concept, acceptance criteria, and clear understanding of what is and not intended to be in the product. So first one is, the primary objective of the inception phase is they need to have the clear idea about the what is the project software scope and what are the boundary conditions. Within the boundary conditions, okay, and they need to check that what are the different types of the operations they need to allow, and is there any criteria to accept the data, and have the clear understanding in the initial stage only. And next one is discriminating the critical use cases. Okay, whenever the stakeholder is taking the problem and discussing with the project manager, with the expert team, okay, they have a business use case model has to be maintained. Okay, so whenever they're doing the business use cases, they need to check all the possibility of the solutions here. Whereas here, discriminating the critical use cases, if the problem is very critical, they need to check that what are the possibility of the solutions for that particular problem. They need to understand clearly, and to get the solutions, better solutions, and the primary scenarios of the operations must be, they need to check that what are the major design trade-offs. So initially they need to check that the architecture part also. Means here they need to have the design trade-offs in initial stage, and have the what are the various requirements, and here the documentation is very important in the initial stage only. And next one here, demonstrating at least one candidate architecture against some of the primary scenario. Here, the architecture demonstration is very important because they need to understand, so what are the various components in the architecture and how this architecture will be impacted to the software project. The next one is estimating the cost and the schedule for the entire project. So they need to understand what is the cost and the schedule for the entire project in the starting stage only. And estimating the potential risk, means sometimes we cannot predict what are the different types of the sources here. So that's why the sources of unpredictability will be happen here. So sometimes we cannot predict what are the challenges or the risk will be happen while handling the projects here. Okay, so here in the inception we can have here engineering stage. So in the engineering stage, inception will be there. So where the management will be considering the requirements, the design part, implementation, and the deployment. So the requirements, they're allocating 50% of the requirements they are going to allocate, and whereas the design part is allocating the 30%, and for the implementation they're taking the 10%, and deployment they're checking the 10%. Okay, so total is 100%. So in the initial stage, they need to have the what are the various requirements and the architecture part for the software project. Whereas in the elaboration, we can have that the requirements is consisting of the 70% and the design part is consisting of 50% and implementation is consisting of 30% and deployment is consisting of the 20% here. This it will be varying depends upon the what are the criteria of the requirements operations are going to use by the management. In the production stage, the requirement means the full requirements. They need to have the full requirements for the implementation part and for the design part more than 90% and the implementation 80%, whereas the deployment only the 40% will be there. And whereas in the transition, can have the everything is completed. They need to complete all the like requirement, design, implementation, and the deployment by the management here. Okay, so what are the essential activities? So what are the main activities will be performed in the inception phases? First, they need to formulate the scope of the project. So they need to understand what are the main requirements. So they need to capture what are the main requirements in the initial stage, and they need to check that what are the various operational concepts has to be used here. Okay, in the information repository for the user view. And here the information repository, they need to define the problem space. So what is the problem space and how to derive this by using the acceptance criteria. Okay, so this must be used for the essential activities. First, they need to design in the inception phase only. Okay, so this is the first. They need to formulating the what are the scope of the project and how to handle this software project here. Okay, the next one is synthesizing the architecture. Okay, first they need to have the, what are the various requirements. Next, they need to go for the synthesizing the architecture. So while they're designing the architecture, the expert team of the architecture, first they need to draw the architecture and have the various types of the components they need to include in the architecture. Okay, and they need to define that what are the various trade-offs and problem space ambiguities and available solution space aspects. So while they're designing the architecture, they need to check that what are the trade-offs during the design. The technologies and the existing components are evaluated. Okay, so here in the information repository, they need to check that sufficient to demonstrate the feasibility. So at least one candidate has to be explain about the architecture and they need to give the brief description about the various components and how the baseline of make or decision such as the cost, schedule and the resources estimated can be derived. Okay, so this is the second point. Whereas in the third one is the planning and preparing a business case here. Okay, the first one is first they need to design, they need to allocate the various types of the requirements, and next one is architecture, the architecture. So they need to define the what are the trade-offs. And the next one is planning and preparing the business use cases. Here, okay, after taking all the possibility of the requirements and the architecture, they need to have the different types of the business cases. It means they need to define how this problem can be resolved. Okay, so alternatives for risk management. They need to check that what is the alternative for the problem and how this risk can be handled very effectively. And staffing, if any problem occurs, if you're not taking the good staff while you're hiring the people, if you're not hiring the good people, then they may be having some risk with. So they need to check that what are the alternatives for staffing and iterations plan. The plan, if any problems are faced during the project, they need to check that what are the plans, whether they need to have the iterations plans or the cost schedules, the profitable trade-offs are evaluated. They need to check that each and everything, like cost of the schedule, whether how much they can gain the profit. Okay. And next one is the infrastructures. So they need to check that infrastructures like tools. What are the various tools they need to use? So they need to come up with the latest technology and the tools and the process and the automation support. So nowadays mainly instead of taking now manually, so more than 80% they're going for the automation support, because the automation support will be giving more quality and schedule and the cost effective also, and it will be reducing the schedule also, and sufficient to support the life cycle development task. So that's why mainly they need to verify about the infrastructure. Okay, what is the infrastructure? How this infrastructures can be used very efficiently during the planning and preparing the business case here. So we have the primary evaluation criteria for the inception phase here. The first one is, do all stakeholders concur on the scope definition and cost and schedule estimates? The first in the during stage is, stakeholders sometimes cannot accept based upon the cost and the schedule. So there should be a debate between from the management as well as from the stakeholders. So initially, to all stakeholders, sometimes the stakeholders cannot agree upon the cost and the schedule, because sometimes the company can have the cost 100 crores and they can take the 3 to 5 years of the project. Okay. Now the stakeholders wants to minimize this cost to 60 crores, and this must be completed within 3 years, or sometimes they can have 2 years. So here that's why all the stakeholders concur on the scope definition and cost and the schedule estimates. The next one is, are requirement understood as evidenced by the fidelity of the critical use cases. Okay, so when the problem is given by the stakeholder, they need to understand what are the various requirements. Okay, and then how the business use cases. First, they need to understand what are the main requirements they require, and planning and the tools. Okay, they need to understand what are the critical use cases. Then only they can go for the what is the scope of the software project. And next one is, are the cost and schedule estimates, priorities, risk and development process credible? So here mainly they need to check that what is the cost and the schedule and the risk which will be happen and the development of the various process. They need to check that each and every evaluation criteria during the inception phase only. Okay, so these stakeholders, they're having the debate between these stakeholders and the management. And next one is, so the fourth one is, do the depth and breadth of an architecture prototype. So while they're designing the architecture, so they need to check that what is the, how much this will be impacted. This architecture will be impacted for the software project. So they need to demonstrate the preceding criteria. It means the primary value of prototyping a candidate architecture is to provide a vehicle for understanding the scope and assessing the credibility of the development group in solving the particular technical problem. So they need to understand what is the depth and breadth of the architecture and what are the trade-offs during the design, and they need to give the brief description about the architecture and how they are going to resolve this problem. And the next one is, are actual resource expenditures versus planned expenditure acceptable? It means initially they are having some resources will be allocated. Okay, this is the plan. Okay, and whereas when they starting the project, so these will be the resources sometimes maybe vary. So they need to compare. So if it is minimal, So the stakeholders can be acceptable. Whereas if it is having more modifications in the resources, then the stakeholders cannot acceptable this what are the resources or the expenditures will be happen during the project. So that's why they need to give the explanation about what is the actual resources and what is the planned resources during the project. Okay. Now we'll see the what are the various inception phases activities will be happen here. Okay. The first one is identify. Okay. So identify the project scope here. Okay. First we need to identify the project scope. This is the first one. Whereas we need to define the project vision. So how this project will be impacted. Okay. So what are the main applications of this project? And we need to identify the stakeholders. Okay. So stakeholders is very important for providing the funding for the project. And we need to identify the various stakeholders. And next one is identify the project risk. Initially, so they need to check that what are the main problems will be faced during the project. Risk will be happen, such as the requirements or in the architecture or in the documentation or in the testing or you can check the in the deployment. So like that we need to check that what are the various risk will be happened during the project. Next one is develop the project glossary. So we need to check that what is the main project description, each and everything, and establish the development environment. So we need to check that development environment, and sound one is develop the prototype. So prototype we need to develop the project. And next one is here conduct feasibility analysis. After developing the prototype, we need to have the feasibility analysis, and here develop the project plan here. Okay, and finally establish the development team here. So after completion of everything, then we need to check each and every phases, who is the effective one to do the project of the software project. So that's why here we need to verify each and every constant of the activity very carefully, because in the starting stage only we need to identify each and every phases very smooth manner, so that it will be completed within the cost and the schedule. Or else in the initial stage, if you are doing improperly, then the cost and the schedule will be varying. So then the stakeholder cannot agree upon the what are the requirements of the resources, the prototype or the architecture what you are using during the initial stage cannot be accepted by the stakeholders. So that's why in the inception stage only, in the starting stage, so we need to identify the various requirements very carefully, because in the inception, the initial stage only, so we need to check what are the possibility of the different type of the scope in a proper manner here. Okay, so these are the various references referred for the inception model.
Like, share and subscribe. Hit the bell icon for more updates.